All right, here we go. Hello. So last time I did something unexpected. I made a postfix to and fixed the postfix conversion on paper, uh, just as a way for me to better understand what the hell I'm doing. So yeah, paper is the best prototyping tool. So go ahead and watch that to get a sense of what the hell is going on. So I spent some time also just refactoring my code a bit. So I moved a bunch of things into different folders. So now my formula is uh, provided here. I am calling the parser from somewhere outside, inside the mod file. And just for myself, to keep in track, I kind of went ahead and tried to visualize digitally this time how my code would process the string. So as you see, there's the same thing that I did on paper, and in the end, I'm getting this postfix presentation of the thing I do. So in the end, as you see, there's like functionality that when we scan the thing, we encounter the operator. So we do B and C multiplication, like in here. Then we add A to it from the stack, like here. Then we subtract the multiplication. So we multiply first D and 2. We multiply it, and then whatever is on the current postfix stack, we subtract two items, one item from another, and then we get 100 and the result of all this functionality here, and we compare these like here. So this is cool, and since I was refactoring on my own without recording that, I'm just gonna show it slightly. So in the mod, I kind of went ahead and deleted, well, not deleted, commented out all the nonsense I had when I was just trying to, prototype how this thing would be done. And naturally, the prototyping is complete, and I just commented out everything. Now in my parse function, all I do is I just get a list of all operands I have. So this is the single responsibility of the parse function, right? And it returns me a result of OK, that everything was fine. After the operand gathering, when I interpreted every character I have, then I'm able to convert stuff to postfix. And I use the same logic I had on a piece of paper. So what's going on? Actually, I'm gonna show Excel, well, LibreOffice side by side. Let's give it some more space. All right. So this helped me to understand what to do. So when we go through the list of our operands, so I was able to just assemble, okay, this is number, this is just some operator, this is a parent, opening parent, another opening parent, this is a variable, this is operand, this is parent, this is another operand, operator, operand, closing, minus operator. So yeah, so when I encounter the primitives, the number or the string or a variable, I just push them to postfix. So in this example, the 100, it goes immediately in there. When I encounter a operator token, as you see, if there's a empty stack, I just push it. If not, then there's some logic going on. So I just loop over what I have in a stack kinda. So if the last stack item is an opening parent, then I just push whatever there is to the stack of items here. So if there's opening parent and there's a plus, I don't care about precedence anymore because it's just operand. So opening parent is not precedence sensitive. If there's operator token, so plus, minus, multiplication, whatever, then I'm looking, okay, the incoming plus or multiplication will have to check against the last item. And if its precedence is bigger, then I'm getting some last item from the stack and just move it to the postfix because, yeah, it's a rule. And otherwise, if the precedence is not bigger, then I just push it on a stack further. And I break out of the loop. And the loop is needed just in case if there's more stuff on the stack and well, let's say there's like a plus and the incoming plus is coming, or a minus. So plus and minus would have similar precedence, and I would need to take the last plus, was it? Yeah, and push it on the postfix, and the minus would come into stack as the last item. So this is a way to create all that. And this never happens for me because the code is just here. It's quite robust. The one thing I did have some trouble was this when I encounter the closing parent. So when we encounter a closing parent, we have to, this is the example, right? So there was some stuff on a stack. We have a closing parent. Then we have to pop all items like multiplication into postfix, and the opening parent would disappear. So I popped 2 items, right? So, and when we encounter opening parent, yeah, we kind of removed it with a pop, and I set a flag for myself for future that there has to be an opening parent if we introduce a closing parent. And this would result in error after I implement error handling. Same stuff here. If there's like precedent stuff happening, then I do expect that, well, something will need to be popped from the stack. And if there's no popping happening, then there's some underflow. I will probably revisit this code because there's some match statements I could be using, I guess, but for now it works. And the best part of all that, so I'm not building AST tree like abstract syntax tree yet, but everything else is kind of the same. There's actually more stuff I could be deleting. When I broke the code into reasonable procedures step by step, and I operated with the same thing I mentioned in the last video, do watch it, that after I envisioned the precedence stuff as a pyramid, it became more clear to me. So this is a visual aid I developed for myself to just understand what the hell is supposed to happen. And when I run the code, provided I didn't delete too much, bam, it actually did exactly what it's supposed to do. I wonder if I could... Alright, let's make it ugly. How do I do this? PM. Alright. So the resulting code that I have exactly has the same structure as I showed in here. So you can see there's a number, 100, variable A. So look here, variable A, variable B, variable C, and then I have operator token multiply, like here. Then there's operator token plus, like here, D and 2 and multiply, D2 multiply. And then there's a, oh, when I was resizing it, destroyed a bunch of text. So multiply here. Then there's a subtract, and less than equal. So the algorithm works technically at this stage when I have the functionality of this. I might not need the abstract syntax tree. I could operate with a stack because I'm not going to implement anything more sophisticated than this, and I could just go ahead and read the, like I could scan all this directly with this stack, with this postfix stack. So I would scan, I would assemble. Yeah, let's actually visualize how I would do it. So I would have a scan, and I would build like execution stack. And let's see what would happen. So 100. So yeah, I would get 100. I'm scanning further, then there's AA. I get BC. So I would slowly consume, like not consume, I would build another stack, BC. Then I see, oh, there's like, let's remove it because I don't need it. Then there's a multiply, right? Immediately, I would not push it to this scan stack I have. I would know this is an operator. I would pop two items. I would multiply them together. And this would become x. The result of this would become x. Then I scan plus. Alright, then there's a plus. Alright, so I pop two items now. This becomes y. Then I see a D and a 2, so I would push it to D and a 2. And then I see a minus. Oh, come on. Alright, pop another two items. This becomes Z. And then I encounter this. I forgot to... Oh yeah, minus. Yeah. So this becomes Z altogether. And then I check if this becomes less than this, like our initial formula once, and I get a true. Do I need to build the abstract syntax tree? I had the idea of it, but it doesn't seem like there's a sense for it. Now, the thing I would need to consider is I will operate with strings, and since I know the types of stuff I want to have, I know that I could have variable d, and inside it there would be an integer, but also in the variable d there could be a string for some weird reason. So if there's a less than or whatever, I would check for, I guess, types, but that would come from other place. So I don't think I need abstract syntax tree anymore. This is going to be a stack-based virtual machine thing. I investigated enough to know that this would be way too much. I mean, the code is stack-based. Lua is stack-based, right? I guess WebAssembly is stack-based. I don't need that anymore. So yeah, there's another session, and visualizing the thing in a pyramid actually made a lot of sense for me. Well, subscribe if you like it. Cheers.